Hello. Yeah, am I audible?
Yes, sir.
Yeah, good.
Yes.
Okay, good morning. Now, welcome back to the class. Now, I think last class we have started with the proximity sensors, right? Now, we'll be continuing the proximity sensor. So, the first thing that we'll try to do now is we'll just recap the one what we had done in the last class. So, proximity sensor basically we understood that it is mainly used to determine how much close the object is and also to detect the presence of the object. Now we have started to discuss the different types of proximity sensors. The number one was the proximity switches, which is mainly used to know whether the object is present or not. Okay, it is not used for making any measurement, though it is mainly used to check whether whether there is a presence of object or not. That's all. Then second one was the eddy current type proximity sensor. In this case, of eddy current type of proximity sensor, we have discussed that whenever this conducting material, okay, is going to come, okay, closer to the object, that is when this conducting material is going to come closer to the sensor, the eddy current developed is going to be more. As there is more eddy current flowing in the conducting material, there will be less inductance is going to be present. That means when the distance between the sensor and the object, if it is lesser, it means that more eddy current, which results in lesser value of the inductance. And if you move this conducting material away from the sensor, so the amount of eddy current generated is going to be lesser because there will be more amount of inertance. Therefore, now you will be correlating with what is called as the inductance value. Okay, inductance value. Okay, that is less inductance when the conducting material is nearer and more inductance when the conducting material is away. Okay, now this nearness and away is nothing but how close the target is to the sensor. Okay, that is about what is called as the eddy current proximity sensor. Then we have discussed pneumatic proximity sensor. It is mainly used for a smaller to detect smaller distances, and in this case, when there is a presence of the object near the port, there will be rise in the output port is going to occur. The amount of increase in the pressure depends upon how much close this object is in front of the sensor. If the closeness is very smaller, okay, if the closeness is very smaller, more amount of pressure. On the other side, if you move this away, the pressure is going to reduce. Okay, so increase or reduction in the pressure can be correlated with respect to the distance of the object in front of the sensor. Okay, so this is what are the things that we have discussed. Okay, right. So with this, we'll move further for the next one. That is the fourth one called as the capacitive type proximity sensor. Okay, right. Now, now in this case, we'll try to understand the how the distance is going to be measured. Okay, so basically the objective is to what? Objective is to measure how close the object is to the sensor. Okay, right. Shall we proceed? Are you there? Are you with me? Yes.
Yes, sir.
Yeah. Okay. Right. Can I know what you mean by how to determine the capacitance of a conductor? Any idea? What you on what basis this proximity sensor would have been designed? Based on what is called as capacitance. What is capacitance?
So ability to hold charges.
Affinity to hold charges. Okay, right. How will you do it? What is the basic principle? Any idea? This is the old concept actually. Okay. What are the basic principle by which you hold the charges together? What is the basic principle of the capacitor or a capacitance or condenser? Okay, that means when you hold, okay, when you separate two different conducting materials in between what is called as a dielectric member, there exists what is called as the capacitance. Okay, that is a charge is going to be created. That means now basically again this capacitive type proximity sensor is a non-contact type, same as your the pneumatic sensor, same as your eddy current proximity sensors. Okay, So it is mainly used to measure the distances. So distances, in a sense, it is not going to be a rotary value. It's a linear value. Okay, so linear displacements can be measured by using capacitive type proximity sensor. Okay. Now the basic principle is going to be this. The basic principle is what? Now I will be having two different metal plates. Those two metal plates are separated by a dielectric material. Okay, dielectric media, and that constitute what is called as a capacitor or a condenser. Okay. Now what is the basic equation of a capacitor? If you can remember, the capacitance of a condenser, the capacitance of a capacitor, okay, depends on the configuration, size and spacing of the plates. Also it depends on the type of dielectric used. So basic equation you try to understand. The basic equation is what? So capacitance C is going to be determined by epsilon naught, okay, epsilon naught, epsilon r a divided by d. Okay, now we have something like this. So this is one particular plate, okay, and there will be one more plate which is going to be present. Okay, so these two plates are going to be filled with what is called as a dielectric member, and I am going to get what is called as a capacitance, that is nothing but the charge. Okay, so this is called as the basic principle. Now the capacitance is the charge what is known to you, and epsilon naught is what? Permittivity of the free space. It's nothing but the air. The permittivity of the free space is nothing but the air generally, and epsilon naught is the value of epsilon naught is going to be 1, right? And epsilon r is the relative permittivity of the dielectric material, okay, which is going to be present here. And then a is the area of overlap between the plates. Okay, a is nothing but area of overlap between the plates. Now what is area of overlap? What is this first of all? Okay, now this is nothing but what? This is nothing but the distance between the plates. Okay, now this is nothing but what is called as a distance between the plates. This is called as the value of d. Right. Next is area of overlap. Okay, that is nothing but you have one plate here and another plate is here. Okay. Now the overlapping, if I just close them off, okay, if I assume d is equal to 0, now this plate will merge with this. Now, okay, now what is that overlapping? Okay, now the overlapping is going to be from, it starts from this point, okay, and it ends up to here. So this I can call it as what is called as the area of the overlap. Okay, is it understandable to you? Clear? Clear? Yes, yes. Clear?
Yes, sir.
Okay, right. Now this is the basic equation. Okay, now till now we have not come to the level of developing a capacitance type of proximity sensor. Okay, now with this basic equation where C is equal to epsilon naught epsilon r a divided by d, how can we design a proximity sensor? Can you just guess how can I do it now? Any guesses? Now this is a basic equation. Okay, now using this, by changing the parameters, can I measure the value of the distance? Okay, let me explain. Okay, epsilon naught is what? Constant. Yes or no? Epsilon naught is what? Permittivity of free space is
Constant.
constant. Okay.
Constant.
Now I will do one thing. Okay. Now what is this value? What is this called as? I am prompting now. What is this called as? What is this? Can you able to see the screen, by the way?
Yes, sir.
Okay.
Yes,
So
sir.
what is this?
Distance between the two
Distance.
plates.
Okay. So distance between the plates. Now, if I play anything with this distance between the plates, what is going to happen now? I will do one thing. I will move one of the plates by certain distance downwards. What is going to happen? What is the effect?
Capacitance will decrease.
Huh?
Capacitance will decrease, no, sir.
Capacitance will decrease or increase depending upon how are you going to move. Now observe, I will not touch upon anything. I will not, any of epsilon naught is constant. Relative permittivity of the dielectric medium, the same dielectric media I am going to use. Area of overlap also I am not going to change. At a particular instant of time, what I am doing is I am only shifting in the same configuration. I am only shifting the value, I am only shifting one of the plate by a distance equal to x, like this. Okay, right? Now, what is going to happen to this equation now? C. What is going to happen to D now? D is going to become D.
Function of x.
Okay, D is going to become function of x, means D plus x is going to be there. Now, with the increase in the value of D, what is going to happen to your capacitance value? Capacitance value is going to decrease, is it not? I am just telling the straightforward one. Now, what is your objective of proximity sensor? What is the objective of proximity sensor? Tell me, what is the objective of proximity sensor? It is used for what?
So to measure distance, sir.
To measure the distance. Okay, mainly the proximity sensor is used to measure the distance. Now, I am trying to do with some arrangements. Now, observe. Okay. Now, I'll just observe these three diagrams. Capacitance sensor for monitoring linear displacements can take the forms as shown in the figure. Okay. Now, in the first figure, what is that I am doing now? In the first figure, plate moves. Okay. And changes the value of D. The value of D is going to be changes. Okay. Now, when the value of D changes, what is going to happen to your capacitance? The capacitance value is going to decreases. Okay, by the moment the value of D increases, okay, now as it is in the denominator, the capacitance value is going to decrease, is it not? Now, the increase, the reduction or increase in the value of C can be attributed to what? Can be attributed to how much closer or how much far you are moving the plate. Are you understanding? Yes or no? Yes or no? If I move this plate very nearer to the other plate, what is going to happen to your value of C?
Increases.
Increases. Is it understandable? Okay. What is that you are giving now? What is that you are giving? You are giving a push to one of the plate. Means to say what? What is that? The push is nothing but what? What is that mechanical parameter you say? That push is that movement is nothing but what? That movement is nothing but the displacement. Yes or no? Is it I am giving correctly? Understandable?
Yes, sir.
Okay, now I am trying to give you the various forms of capacitive sensor. Okay, the various forms of capacitive sensors are going to be, one method is going to be by moving the plate away from the other plate. When I move the plate away from the other plate, the value of D is going to become D plus X, and incidentally, the capacitance value is going to decrease. Okay, right. Now, in the second case, what is that I have done? One of the plate I am going to move in an horizontal direction. Okay. When I move the plate in an horizontal direction, what is going to happen to the area of overlap? Is it going to increase or reduce?
To decrease.
Decreases, because earlier,
Reduce.
yeah, earlier the area of overlap is going to be from this point till this point. Is it not? Earlier. Okay. So this is the initial case. I am not going to change anything. I am not going to change D. First case I have done it. In the second case, what is that I am doing? I am keeping the same value of D. I am keeping the same dielectric material, but I am pushing one of the plate in an horizontal direction. That's also movement. That's also movement in the horizontal direction. When I does this, my area of overlap is going to reduce. When my area of overlap is going to reduce, it will have a corresponding impact on what? Corresponding impact on C, because C from the previous section, we know that C will be equal to epsilon naught epsilon r A by D. Now, by keeping all the other things constant, if A increases, C increases. If A reduces, C is going to reduce. That means I am moving the value of, I am just changing the value of D in one case. That movement I am measuring in the form of capacitance value. Then second case, I have moved the area one of the plate in a horizontal direction. Again, that movement I am going to call it as displacement. How much I have moved will directly impact on what is called as a capacitance. That means what I am doing is I am not directly measuring the value of the distance. Rather, I am measuring the value of the capacitance, which indicates how much the plate has moved in the x direction or in the y direction. That is with respect to what? A and D. Okay. Then one more parameter is relative permittivity. That means what? the dielectric media, okay, the amount of dielectricity, the dielectric media present, I am going to change. Okay, that means now here the dielectric media is not present there. Okay, now when I shift the dielectric media, then again that is going to have a direct impact on the C. Now by changing the value of D, okay, by changing the value of A, by changing the value of epsilon R, relatively correspondingly the value of C is going to change us. Okay, now all this you are giving what? All this you are giving a displacement. You moved the value of, you moved one of the plate. That means the distance, auxiliary axial movement. Now again A has been moved, the permittivity has been changed. Okay, now the amount of change in the value of C is an indicator of, it's an indicator of how much the plate have been moved in the horizontal direction or in the vertical direction, or how much amount of dielectric media has been moved from the previous case. Now in a way we can able to measure the amount of distance which is moved. So this is the basic principle. Now just observe here, when you go further, there is some other discussion I just want to make. Now we'll come back to the first case. Okay, that is, what was the first case? In the first case, what is the form of capacitor? How I have designed the capacitor in the first plate? What is that we have done? Please note down. Please,
Increased DC.
yeah, please take a notebook and write this. Okay, now in the first case, what is that I have done is, if the separation between the plates D is increased, okay, I have increased the value of D. Okay, right? Now what is going to happen to your capacitance equation? So C is going to reduce, is it not? Yes or no? Please note down this. Please
Yes,
note
sir.
down this. C is going to reduce by delta C. So the value of C is going to become C minus delta C equal to epsilon naught, epsilon R A. Nothing I have changed. Denominator is D earlier, and with the D I am going to get C. But with D plus X I am going to get C minus delta C. It means what? The capacitance value is reduced. Now let me take the equation for change in capacitance as a function of initial capacitance. That means change in capacitance is your delta C, initial capacitance is C. Okay, now we shall call this as equation number 2, and we shall call the previous basic equation as 1. We'll take 2 by 1 now. Okay, so 2 by 1 is what? C minus delta C divided by C. Okay, it is epsilon naught epsilon R A divided by D plus X. Okay, so D will go on the other side, D divided by epsilon naught epsilon R A. So this will get cancelled, this will get cancelled. So C minus delta C by C, that is 1 minus delta C by C is equal to D divided by D plus X. Now my requirement was to calculate the change in capacitance to original capacitance. Okay, so delta C by C. What is delta C by C? Delta C by C is equal to 1 minus D divided by D plus X. Okay, right. Now observe this equation carefully. Please observe. Please just do so small mathematical equation. Okay, mathematical working. Now delta C by C is equal to 1 minus D divided by D plus X. In this equation, which is the parameter that you are changing? What is the input parameter? Yeah? Tell me. What is the input parameter? What have you changed?
Displacement, sir.
Displacement.
X.
Okay, yes, exactly. Okay, what you have changed is the value of X. And for this change of X, what you have got is the change in the displacement. Now, if you observe this equation carefully, that is delta C by C is equal to 1 minus D divided by D plus X. So, is this equation is a linear equation or a non-linear equation?
Linear.
Okay, now D divided by D plus X means for every change in X, is the value of C linearly increasing? No. Okay, right, observe. Okay, this equation is non-linear, that is change in capacitance delta C and displacement X are non-linear. Okay, now just observe this very important parameter. Okay, now the change in value of X and the delta C is going to be non-linear, and if it is going to be a non-linear, what is the problem that you are going to get? If you design a sensor with a non-linearity, what is the error that you are going to get? Can you please recollect? What is the error that you can get? If it's a non-linearity, what is the error that you can get?
So hysteresis, sir.
No, you are nearer. Not hysteresis. One more error. Can you please quickly? Okay. Yeah. Okay. Now what is this error called as? Okay. Now there is an error which is going to come called as a non-linearity error. What is this non-linearity error? Now with the change with the input, there is going to be an output increase in the output. Okay. If there is going to be any non-linearity function, okay, then this is going to take another path. Okay. Now this difference is going to be what is called as this distance is called as the non-linearity error. Okay. Now what you need to do is basically when you are going to design the sensors or the transducer, always to make sure that there should not be any non-linearity which is going to be present. Okay. Now in order to reduce this non-linearity, okay, what is that we are doing is, to this non-linearity can be overcome by a push-pull or differential capacitor displacement sensor. Now just observe, we have discussed about the capacitance sensor. We understood the basic equation. Then three different forms of capacitance sensor we have discussed. In the first case, we have moved the value of D in a y direction. Second case, we have moved the one of the plate in the x direction. In the third case, we have moved the dielectric media itself. And those are the three cases. Then the first case we took, that is, if you move the value of D in one direction, with the increase in the value of D, the capacitance value is going to decrease us, and we took the change in capacitance to original capacitance, that is delta C by C we are done, and we observed something called as a non-linearity, and the requirement is this non-linearity has to be reduced. Okay. Now how to reduce this non-linearity? To reduce this non-linearity means I want the function to be linear. Okay. Now this non-linearity can be overcome by another method called as the push-pull or differential capacitor displacement sensor. Now what is this push-pull type is going to be? Now if you observe, just observe here. Now in case of push-pull type, we have three plates which are going to be present. Okay. So this is as usual one plate and this is another plate. Now in between I have put one more plate now. Okay, intermediate plate I have put now. Okay. Now what is going to happen is this is having the three plates with these two plates forming a capacitors C1. Okay, please understand. And the top one and the middle one constituting capacitor C1, and the middle one and the bottom one will constitute what is called as C2. Okay. Now in this case, I am going to move one of the plate, that is the middle plate, by an amount equal to x. What is the effect? If I move the one of the plate by an amount equal to x downward, that is the central plate, if I am going to move the downward, what is going to happen to this this capacitor C1? What is going to happen to C1 is equal to what now? Tell me. Are you getting now? Can you able to view this on the screen?
Yes, sir.
Okay, now this was the three plates what we have got. Okay, so this is your top plate. Okay, and this is going to be the bottom plate. Okay, right. Now this I am going to move by an amount equal to x, and here I am going to get capacitance C1. Here I am going to get capacitance C2. Okay, right. Now what is going to happen to my value of C1 now? Please observe. What is C1 now? Tell me. C1 is equal to what? C1 is equal to what? Tell me. Equation.
Epsilon naught.
Epsilon naught.
Epsilon naught.
Or A divided by D
D plus X.
D plus X. Okay. So similarly, what is my value of C2 is going to become now? Epsilon naught, epsilon R A divided by D minus X. Is it clear? This is the first equation. Now, just observe now. What I will do now is, I will make this C1 as one arm of, I will make C1 as one arm of AC bridge. Okay. C1 as one arm of the AC bridge and C2 as another arm of AC bridge. Another arm of AC bridge. Okay. If I do so, the effect of this is, if I do so, the effect of this is, okay, that is an alternating voltage E is going to be developed. Okay, that is E will be the alternating voltage is going to be developed across what? Across capacitance C1 and capacitance C2. Okay, can you able to see this? What is that I am writing? Yes or no?
Yes, sir.
Okay, right. So E is equal to alternating voltage, which is going to be developed across C1 and C2. Okay. Now, when we are going to consider, because of this C1, okay, because of this C1, okay, so the value of E is going to be what? E is the difference between E1 and what is called as E2. E is nothing but E1 and E2. This is nothing but the resultant alternating voltage. Resultant alternating voltage. That is, because of C1, because of C1, I am going to get E1. Because of C2, I am going to get what is called as alternating voltage E2. Hence, the resultant alternating voltage will be equal to E1 minus E2. Okay. Now we'll try to calculate what is the value of E. Okay. Now E1 is going to be what? Okay. E1 in form of, E1 will be, that is, when you are going to make this in one arm and the another arm, okay, E1 will be equal to E into C2, okay, divided by C1 plus C2. So this is from the basic equation of capacitance. The basic equation of capacitance. Okay, if I make two different arms, okay, so this is what is that I am going to get. E1 is equal to E into C2. Okay, E into C2 divided by, anything mixed up? Is it mixed up? Okay, right. Now, what is the value of, now I'll just write again. Oh, sorry. Okay, sorry. Okay, right. E1 will be equal to now what? Okay, E will be equal to E into C2 divided by C1 plus E1 will be equal to E into C2 divided by C1 plus C2. Okay, right. Now what shall we do now is, we'll substitute the value of C1 and C2. Okay, right. So what is going to happen? Can you give me the value of E1 now? Can you give me what is E1? Are you all there? Hello?
Yes, sir.
Okay, so what is the value of E1? E1 will be E. What is C2? Tell me fast. C2 is? Tell me.
Epsilon naught A
A
divided
by D minus
by
X.
X.
Correct? So C1 is epsilon naught A divided by D plus X plus epsilon naught epsilon R A divided by d minus x. Okay, right? So epsilon naught epsilon RA will go away. Okay, so it is e by d minus x. So we'll have d plus x into d minus x. Okay, so it becomes d minus x plus d plus x. Is it I'm right? Is I'm right?
Yes, sir.
Okay, so therefore E1 is going to become what now? D minus x will go away, and then x and x will goes off. Okay, then it becomes E into tell me E into tell me
D plus X.
d plus x will go to the numerator divided by what is called as d plus d, which is 2d. Okay, right. So this is the value of E1. Okay, right. So similarly, okay, what you are going to get? Okay, E2 again. Okay, so E2 is going to be due to what? E2 is going to be due to the capacitance. So E is going to be alternating voltage, E C1 divided by C1 plus C2. Okay, so E1 is equal to E C2 divided by C1 plus C2. E2 is equal to E C1 divided by C1 plus C2. Similarly, you just substitute directly. Okay, so E is going to be, okay, again epsilon r A divided by d plus x divided by epsilon naught r A divided by d plus x plus epsilon r A divided by d minus x. Okay, so upon the calculation directly we can take epsilon naught r A, we can able to remove it off. Okay, so it becomes E2 will be equal to what? Tell me, E into
D minus X.
okay, E into d minus x divided by 2 into d. Okay, so this is the value of E2. Now we have got the alternating voltage E1 and alternating voltage E2. Okay, now what is required for me? We require what is called as the output voltage, that is nothing but alternating. Okay, so we have got what resultant alternating voltage. Okay, is E will be equal to what? E1 minus E2. Okay, right. So what is E1 now? Okay, E1 is E d plus x divided by 2d minus E into d minus x divided by 2d. Okay, so what is the value of E is going to be? If I take E by 2d outside, so it becomes d plus x minus d plus x. Okay, right. So the value of E is going to be now will be equal to E into what? E into dd gets cancelled, 2x divided by 2d, so it becomes x divided by d. Okay, right. Now just observe. Okay, now just observe the output voltage E. Now earlier what was the case now? Okay, if you remember earlier what we observed is delta C by C. Please observe what was delta C by C? 1 minus, tell me, 1 minus
D divided by D plus X.
d divided by d plus x. Okay, right. Now observe this x. X is what is called as the displacement, and delta C is going to be your change in capacitance. And this equation is going to give you what is called as the non-linearity. Okay. Now to reduce this non-linearity, we have done what is called as another method called as the push-pull sensors. Okay. Now by doing that, what we are going to get is E is nothing but E into x divided by d. Okay. Now observe the changes now. What is x here? X is the same displacement what you are going to give, and for this value of x, you will be having what is called as the value of E. Now what is the voltage now? The voltage is what? The voltage is the linear function of displacement. The voltage is linear function of displacement, and hence the effect of this is what? You have converted from non-linearity into what is called as the linearity. Therefore, so three different methods are going to be there here. Okay, so the other different methods are going to be, so this is the what is called as the case of the push-pull type sensor. The various different types of capacitors are going to be like this. If you observe, okay. So once again, okay, right. Now, what is the condition now? The various forms of capacitors. Okay, once again, capacitance, proximity sensors. Okay, so one is going to be by what? One is by moving the plate in y direction. Correct? Okay, correct. This is the first one. This is what is the case, and this plate you are going to move. Okay, so this is one method. Second method is going to be by moving the plate in x direction. Okay, right. Now in the first case, which parameter is going to change? Which parameter of the basic equation changes? Which parameter of the basic equation changes?
Area.
Distance between the plates.
Distance between the plate, d changes. Okay. In the second one, so this was the initial case. Okay, right. So what is that you are doing is you are moving this away. Okay. So what is that? What is that? It's changing now. Everything remains same. What is that going to change? Area of overlap is going to change. Okay. Third one is going to be by moving the dielectric itself. By moving the dielectric itself. That means what? Now this was the case, and earlier it's going to be from year to year completely is the dielectric medium. Okay. Now what is that you are doing now is, okay, we'll make sure that the amount of dielectric is going to be reduced. Okay, the amount of dielectricity is going to be reduced. Okay, now this is going to be what? Nothing. Okay. So now due to this, again we are going to be, you are changing the epsilon r. So now C is equal to epsilon naught, epsilon r A divided by T. So by changing this one is going to be here. Okay. Second one is going to be this, and third one is going to be this. Okay. So these are the three methods. Now after this, what have you observed is, you observed what is the problem? The problem was the non-linearity. Okay. Non-linearity. Now to reduce this, to avoid this non-linearity, what have you done? To avoid non-linearity, what type of proximity sensor you have developed? What is the type of sensor called as? I want to make non-linearity to the linearity. Okay. So type of sensor is, tell me what is that? Just now we are done. Okay. It is called as push-pull type sensor. Okay. So what is the simple objective of push-pull type? Okay. Now we will be having three. I am just writing for the understanding. Right. Okay. Now this forms one plate. This forms the other plate, other group. Now you are pushing one. It means that one is be pushed and the other is going to be pulled. Okay. That is the meaning called as push-pull. If you consider one case, if you consider this case, what you are doing? You are pushing the one of the plate downward. If you consider the second case, okay, you are pulling one of the plate down. Okay, so that is what is called as a concept of push-pull type sensor, or it's also called as the differential type sensor. It's also called as the differential type sensors. Okay, right. So this is the other method. Okay. Now one more method. Okay, so this is about the capacitance sensor. Then one more possibility is going to be what? Okay. Now what we can do is we'll have one more method. Okay, which is going to be something like this. Okay. Now you make only one plate. Okay, you make one plate. This is your you make this into earth. Okay. So this is the object. This is the object. Okay. And then you have only one capacitor plate. Okay. So this is your capacitor plate. Okay. Now earlier what we used to say, and in between this you will be having what is called as the dielectric media. Okay. Right. Now what is this you need to understand here is, in all the previous cases, here you have one plate and you have another plate. Correct? Right? Again you have two different plates separated. and here you have 3 different plates. But here I am having only one plate. Okay, I am having only one plate, and another plate. What is that I am doing is I am making it as an object itself. Okay, the other form of capacitive proximity sensor, it consists of only single capacitor plate. It consists of single capacitor plate. It consists of single capacitor plate with the other plate. Okay, this is the other plate. Okay, which is going to be called as what is called as the object. Okay, object and earthed, which has to be metallic and which has to be earthed. Okay. Now what is going to happen now? If you move this one of the plate nearer, okay, if you move this one of the plate nearer, this object is fixed and you are moving only one of the plate. That means what? You are changing the distance between the plate, and yet you are going to determine what is called as the value of C. Okay. So these are the other different types of what is called as the capacitance sensor. Okay. Right. Then we'll have one more type of the proximity sensor that will take and will finish. Okay. So that is called as, once again, okay, right. So that is called as what is called as, just make a note, photoelectric proximity sensor. Okay, photoelectric proximity sensor. Okay, so based on what concept this sensor might be designed? Based on what concept this sensor is going to be developed? Any idea?
So using photovoltaic cells.
Exactly. Okay, so it is, the effect is called as photoelectric effect. Okay, photoelectric is something, but what's happening? What is the input?
Light source, sir.
Light source, simple. Okay, light source is the input. Okay, now we are considering light source as the input, and the output is going to be converted into the voltage. Output we are going to get in the form of the voltage. That is called as photoelectric effect. Okay, photoelectric effect is something but photons converted to the voltage, called as the photoelectric effect. Now in this case, we have 2 different types of the sensors are going to be used. Okay, one is called as the reflection type. Okay, there are 2 types of proximity sensors here. One is the reflection type proximity sensor. Reflection type proximity sensor. Other one is called as through beam. Okay, other one is called as through beam type proximity sensor. Through beam type proximity sensor. Okay, right. I will just have a simple diagram. Okay, very small diagram. Okay, just let me make it up. Please take a diagram. Okay, so okay, this I am going to call it as LED. This is your photo detector. Oh, I have to. Okay. Sorry. Okay, I'll write neatly. Okay. So this is your. I have to write big, I think. Is it visible, whatever I'm writing to you?
Yes.
Okay, I'll write bigger. Okay, so this is called as adaptability. Okay, photo detector. I think now it's probably clear. Okay, right. Now I am having what is called as the target. So this is the target. Okay. Okay. So this method is called as reflection type proximity sensor. Okay. Now what's happening? Can you just understand what is this method? So what is this type? First of all, what for we are doing this? What, under what category of sensor it is going to come? It's a proximity sensor. First of all, it's a proximity sensor. Okay. In this proximity sensor, we are using photoelectric as the phenomenon. Okay. We are using photoelectric phenomenon to determine whether the presence of the object is there or what is the distance. Okay, now what is going to happen now? What is LED here? What is LED? What is LED? What it does?
Light emitting diodes.
Light emitting diode. Okay, now that is nothing but what is this? It is called as the source of the light. Is it not? Correct or what? It is called as the source of the light. Now the light is going to fall on what? The light is going to fall on the target. Okay. Now in turn, the target is going to reflect the light, which is going to be detected by what is called as the photo detector. Very simple operation. Very simple operation. Okay. So we have in the photo, or what is that? In the reflection type proximity sensor, light emitting diode is the light transmitting source. Simple light transmitting source, and photo detector is the receiving source. Okay, right? And when the light rays falls on the target is going to receive that light, and the light will be reflected back, okay, to the photo detector. Now what is that concept of proximity sensor you are going to do here is simple. Assume the target is going to be away. If the target is going to be away, okay, now it's very simple that now this is your sensor, okay, this is your sensor, this is your target. Okay, if the distance between the sensor and the target is more, okay, now the distance, the time taken by the photo detector to receive the reflected light is also going to be correspondingly more. Yes or no? Yes or no? Right? Yes or no?
Yes, sir.
Okay, now if I bring this target nearer, if I bring the target nearer, will the photo detector gets the response faster or slower?
Faster.
Faster, because now what I mean to say is, depending upon the amount of distance that you are going to move this target in front of the sensor, accordingly the photo detector will detect the light. The detection of the light by the photo detector, please understand, the detection of the light by the photo detector depends upon how close or how far the target is in front of the sensor. If the target is very nearer to the sensor, the photo detector will receive the reflected light from the target faster, and on the other side it is going to be late. Now that time gap, okay, that time gap indicates what? The time required to receive the signal indicates what is the distance of the object in front of the sensor. Okay, so that is called as the reflection type proximity sensor. Okay, so in case of the second one called as a through beam, just observe this and tell me what are you measuring. Okay, now this is one, this is called as your LED. Okay, then I will be having one more here. So this is my photo detector. Okay, right. Now what is this called as? This is called as my optical axis. Correct or what? Okay, right. I am transmitting the light, photo detector is receiving the light. Okay, I am transmitting the light, photo detector is going to receive the light. Now what I will do is, I will bring the object. Okay, I will bring the object, I will bring the object very nearer. Okay. Okay. This is the object now. Okay. Right. I will move the object here. Okay. Right. Now you tell me what is that I am, what is the intention now? What is that I am going to get here now? This is the through beam type. Okay. This method is called as through beam type. What is that you are measuring, or what is that you are doing here? You make the object to cross the optical axis. Okay, right. Assume this is on the other side. If I'm going to, on the application side, if I'm going to say, assume this is your conveyor. Assume this is going to be your conveyor. Okay, the conveyor is just moving. Okay, on the left of the conveyor you have placed LED. On the right you have placed the photo detector. Okay, this is the object. Okay, some objects are moving. Okay, as and when you produce, the object is moving on the conveyor. Okay, now this object, if this comes here, what is that? What is the meaning? Now this is the object now. Okay, you have pushed the object. The object has blocked the optical axis. What is going to happen? Are you one first question? Question number one is, in through beam type, are you measuring what is the distance of the target to the sensor? Are you measuring anything here?
No, sir.
Anything that you are measuring here, please understand. Anything you are measuring?
No.
No, you are not measuring anything. But what is that you are doing then? If you are not measuring, what is that you are doing then?
The presence of any article.
Okay, simple. You are just measuring, you are just trying to understand, is there any presence of an object or not? Okay, that means when are you going to know that there is a presence of the object?
So when from LED, the light could not be detected by the photodetector.
Simple. Okay, very simple. As long as the photo detector detects the light, that means there is no interference. Okay, there is no intervention of any object. Okay, by the moment the object crosses the optical axis, correct? By the moment the object crosses the optical axis, there is going to be a cutoff of the optical axis is going to cutoff of the signals is going to occur. Hence, photo detector will not going to detect. Every time photo detector will not receive the signal, it means that some object has crossed that optical axis. So the number of times the photo detector has not received the signal will be equal to that many number of time you have sensed the presence of the object in front of the sensor. Yes or no? Is it clear? Right? Is it clear?
Yes, sir.
Yeah, so this is the case of what is called as the photoelectric proximity sensor. Okay, now just observe. Okay, I just want to summarize. Okay, now we have started with what is called as the proximity sensor. Okay, so proximity sensor is used for what? It is used for number one, to detect the presence of the object, to detect the presence of object. Number two, it is used to for what? To measure the closeness of the object to the sensor. Yes or no? These are the two objectives of your proximity sensor. Is it clear to you? Yes or no? Yes?
Yes, sir.
Okay, right.
Yes, sir.
Based on this, we have done some different types of proximity sensor. Okay, what are the proximity sensor we have done? Number one, what is this? Tell me. I'm just consolidating. I'm closing the proximity sensor. That's fine. First one, first type of proximity sensor. What?
Reflection type.
No. First one. Proximity switches. Okay, right. Proximity switches. Okay. So out of the above objective, which objective it has covered? The first Roman number one or Roman number two? Which objective is going to cover the proximity switches?
One, sir.
True beam type.
Okay, right? The first one. Yes or no? Second one was what was called as eddy current type proximity sensor. Eddy current type proximity sensor. The second one. Okay. This one is going to be used to measure the closeness of the object. Third one we have discussed was, what was the third one?
Pneumatic.
Pneumatic type. Okay. Third one was pneumatic type proximity sensor. This is also going to be used to detect, to know the measure of the closeness of the object. Third one. Okay. Right. What was the fourth one now? Okay. Fourth one. What was the fourth one? Huh?
Capacitive.
Capacitive type. Okay. Fourth one was capacitive type. Okay. Again, this is also used to measure the distance. Correct? Fifth one was what? Under capacitive, we have different types. Please remember. Fifth one was the photoelectric type proximity sensor. Under photoelectric, there was two things. One was, what was first one? Reflection type. Correct? First one was reflection type, which is used to know the second objective. Yes or no? Are you understanding what I am doing here? Okay. Right. Then B is what? B is through beam. Through beam. Okay. So this is used for the first objective. Okay. Now these are the the various different types of the proximity sensor which is going to be present. Remember, now I am come to the conclusion. Now I am telling you clearly, in the exam, you may be directly asked, okay, right? Questions going to be like this. Okay, questions is going to be explain proximity sensor. Simple. Explain proximity. So explain with need sketch proximity sensor. Okay, if a person don't want to look at the different methods, he simply say explain with a need sketch proximity sensor. So now you have various different options to write. Some question paper has observed that specifically explain, okay, the proximity switches with need diagram, explain eddy current type proximity sensor, explain capacitive type proximity sensor. Okay, so this might also be asked. Okay, so this is what is that I have told in the beginning of this particular topic. Okay, the question may be broadly on the proximity sensor straightforward. In that case, any method you have to pick and write, or else generally he is going to come down to a particular type of proximity sensor. Okay, right? So this is about the concept of the proximity sensors. Now I'll just stop at this stage, proximity sensor. Then next class when we come back, we'll understand what tomorrow. Okay, we'll understand what are the different types of light sensors. Okay, so we are done with all effect sensor, magnetic sensor we are done. Then proximity sensor, some five different types of proximity sensors we are done. Then we have light sensors. There we'll be understanding 3 different types of light sensors. Okay, right? So I'll just stop at this stage. Okay, so you please type your USN number. Okay, so before leaving the class. Okay, so I'm done with my class. So thank you. So please type your USN. So maybe 2-3 minutes.